What's up, y'all? David here, the founder of 11624, on our way to PPL Pro Labs in Boca Raton to go ahead and get our paddles tested. We're gonna see how it goes and decide between two models which one we're gonna make, and show you all, durability, all the testing that the paddles go through before they get to you to make sure they're high quality. So here we go. What's up, y'all? It's David, founder of 11624 here. I am out at PPL Labs today in Boca Raton, Florida. They're the official testing contractor for UPAA and certify the paddles to be used on the PPA tour. So we're here doing a bunch of R&D testing on our new paddles and want to give you an insight into what goes into the testing process and how we ensure our paddles are durable and remain compliant throughout the process. So come on, let's go in. So we're gonna head back to the lab here. Welcome to us. So here we are in the lab. We're out here testing some of the paddles now. We've got the ball cannon, we got the durability machine here, and then we'll take you all through and go through some of the tests that we're doing today and show you some of the process. All right, so here we have the spin test. So how this works, we have the piston cannon, which shoots about 40 miles an hour at the paddle, which is on a 30-degree angle. And then there's a high-speed camera in the background that will go ahead and record the whole ball hitting the paddle. And then they'll use software at the end to count the revolutions per second. And that's how we get the spin number. And they'll go ahead and shoot 6 balls at the paddle and then take an average of the 6 balls.
So even on you take an elongated paddle, and I feel like it's got a different sweet spot closer to the top of the paddle versus a standard or a wide body.
For spin, we test currently in our SLP. You can find it online. It's at a 5-inch location. Right. There are studies that we have in the process.
Sure.
Looking into this, seeing if it's better to test in different locations of the paddle. But currently, 5 inches versus PV core, we isolate the sweet spot. So we'll test all the center line, find the sweet spot, right? But for spin, we test the center. So this is our new ABI machine. It's currently not on, but I'm just going to talk about it a little bit. It's taking a process that currently we use a vise to break in a paddle, but this is completely automating it. So we have control of not only the depth to which we can break in a paddle, but also the force with which we compress a paddle. And there's also control over the rate to which a paddle is moved through that compression. So we have this bottom carriage here, which is on its own axis that can pull the paddle and move it back and forth. And then we have this axis, which is the axis that actually compresses. The rollers are customizable. So the two that we currently are using in internal studies are just these flat rollers, but it's also possible to roll in something like a 3-point bend and any other kind of configuration that you want to develop.
So do you think this is like a good proxy then to how paddles break in the real world, or do you think this will help eliminate the paddles that do break beyond, like within the first few uses?
So this is something that's currently being studied, right? Because in the real world, it's hard to know. When you play with the paddle, it breaks in a certain way, and it breaks in uniquely for every single person, right? Because every single person has a different play style. They hold it differently. They swing differently. They hit with a different force. So that being said, you can never really perfectly replicate how a paddle is going to break in when it's being broken in the field in real life. What we can do is, like, for example, with this machine, I can break in the entirety of the face of the paddle consistently, right? Versus when you're playing with it, maybe you are a very consistent player and you always hit at the 3-inch location. You're going to have a grouping of break-in at the 3-inch location, right? It's very hard to replicate that. With the vise, we focus a little bit more on the tip of the paddle, A, because limitations of how it is, and B, because our original thought process, well, most of the time people hit with the top half of the paddle, so that's how we're going to break it in.
Not all of us here, but yeah.
But basically, and that's part of what we're studying is, like, does that make a difference, right? Is it a function, is how a paddle performs after it's broken in a function of its structure or a function of how you hit with it? And this machine allows us the flexibility of, okay, we can break it in a very specific location if we want to. We can break it in along the entire face. what can we more closely correlate with what actually happens in the field with a real paddle that's been broken in.
This is a great test, and I'm very excited that it's being put into use soon because it'll help eliminate those paddles that break right away. Plus, we as manufacturers get to see, hey, like it's on us now not to make something that breaks and that lasts, and it's better for you, the consumers.
It's also interesting, and I can't speak too in detail about this because this is more on the design side of things, right? This is what you guys figure out of like the internal structure of the paddle. You can have a very simple honeycomb sandwich, right? And that's relatively clean break-in because you have a consistent homogeneous material structure throughout the paddle. But then when you start playing with something like a floating core or foams or any other creative design decisions you could make, that's when the break-in gets really interesting because no paddle will break in the same way as the next. And that's when you really start to see the sweet spot shift as you break in a paddle. Right, and it's unique for every paddle. So. And
all very interesting. So that's part of the reason we're here today, to learn more about our paddles and how they break in, what we expect to happen. Do they break in at all? I mean, every paddle breaks in, but how much do they break in? So yeah. So tell us more about yourself, how you got into this. What's your favorite part of being at Pickle Pro Labs? Tell us more.
Hi, my name is Lisa. I'm one of the engineers here at Pickle Pro Labs. And I got into this job because I loved pickleball and I wanted to know more. It actually happened quite by accident. I was getting a tour of the lab one day. I guess Gary saw that I was very curious and asked me if I wanted to be involved. And I originally said no because I had some other projects I was working on, but over time was involved with on-site testing and kind of got sucked in because how can you not be excited about pickleball and the engineering that goes behind it? Because literally, we're all learning about it together, right? And there are no concrete answers yet. And I love being a part of the process of finding those answers to the questions that everyone's asking.
That's awesome. So what kind of background do you have?
So my background is in aerospace engineering. I have an undergrad degree in aerospace engineering and then my master's in aerospace systems engineering and entrepreneurship and innovation.
That's awesome. I was going to ask what your favorite paddle was, but I don't know if you can say that on camera.
I cannot say that, but I will say that I love trying out different paddles. I think it's very interesting to see how, I think one of the things that I like to do when I try different paddles is to watch the pros that play with those paddles and see how they change their mechanics or their grip and to see how different pros play with the same paddle. Because it's quite interesting because people change the way that they play and you can get different things out of a paddle based on how you use it.
Use lead tape.
It depends. I use lead tape sometimes when whenever I start with a paddle, I usually keep it clean. I don't add anything to it. I play with it clean. And then at a certain point, once I have, I guess, figured out how I feel with this paddle, I'll add it based on what I think I need a little bit more. A lot of people like to put lead tape at the throat. I'm a tip of the paddle person. I like it because it allows me to get a little bit more spin, a little bit more power on my serves. And also when I'm up at the kitchen line and I need to be on offense, I like the power that it allows me to generate.
And what's your favorite paddle shape?
I vary. It depends on what I'm playing. If I'm playing singles, it's probably an elongated paddle. If I'm playing doubles, not like a square elongated, but I really like that curved top edge of a paddle. Not sure why. It does, in my opinion, have a little bit less comfort in terms of the sweet spot, but I just have gotten used to it, and maybe it's something to do with dinking and the shape of the paddle and how I feel when I use it.
Yeah, we hear that a lot. So the pro shape might be coming. All right, so now we are here testing for PEF, which is the paddle efficiency factor. So how fast the ball comes off the paddle when shot at 50 miles an hour. So what happens here, the ball's loaded into the cannon, shot at 50 miles an hour. It's clamped in on a hinge. So as the ball hits the paddle, it shoots back through some light gates, which measure how quickly the ball rebounds off the paddle. And that's the paddle efficiency factor and kind of how we put a cap on power. All right, that finishes up our day here at Pickle Pro Labs. We tested a bunch of iterations of the new paddle. We learned a ton. What materials make a difference between the spin test, the PEF, deflection, as well as the break-in. So we've kind of decided on which paddle we're gonna make. Very excited about that. And a huge thank you to Gary and the team at Pickle Pro Labs for having us out for an R&D day. That was awesome. Very excited by what they're doing now, as well as what they're working on coming up. So they're putting a ton of research into balls, paddles, everything to make the game, keep it fun and safe for everyone. So big shout out to them, thank you. We're excited. Hopefully everyone enjoys the new paddles.